Hello, it's Mrs. Pound, and I am back with a new chapter, Chapter 1.3 on atomic structure from Purposeful Designs Physical Science. The first section we're going to talk about is Section 1.3.1, and it's the early models of the atom. Now, one thing we have to understand is that as scientists gather new information, they make different models. And so science is changing. It's not just staying the same because our understanding is changing, especially about very small things like atoms that we're experimenting on, because we cannot directly see them. We have to rely upon indirect evidence to guide our understanding about atoms. And so that's why these models have changed so much with new information. It also depends on what new technology we have available to us to help understand things like atoms as well. So our objectives for this lesson are to analyze methods used to determine the structure of an atom, compare the 5 main atomic theories, and describe the current electron configuration around the nucleus. So let's start with John Dalton. He created the first atomic theory after he became interested in the concept developed by Democritus, and after he made several observations concerning the behavior of air. Now, Democritus was an ancient Greek. He said that matter could be broken down into small particles, and he called those particles atomos. And he believed that after it was broken down into an atomos, that it could not be broken down further. However, Aristotle disagreed with him, and Aristotle's ideas stood for the next 2,000 years. According to Aristotle, matter could be broken down indefinitely. But Dalton rediscovered Democritus's ideas through his experimentation. His theory included 4 key ideas. Number 1, all matter is made of atoms. It is indivisible and atoms, are indivisible and indestructible building blocks. He thought the atom was like a solid round ball. That's why I have that picture in the background. The second thing was, he said, all atoms of a given element have the same mass and properties. Atoms of different elements have distinct masses and properties. The third thing he concluded was that compounds are combinations of 2 or more different types of atoms in fixed proportions. And his fourth conclusion was a chemical reaction is a rearrangement of atoms. Now, with further research, there are 2 key ideas of his that have been definitely proven wrong. The first one is that atoms are not indivisible, indestructible building blocks. We have found that they are made of smaller particles, protons, neutrons, and electrons, and even these smaller particles are made up of even smaller particles that you could research if you're interested in that. And the second thing that we have found that is wrong is not all atoms of a given element have the same mass. Many elements have what we call isotopes that have different numbers of neutrons that affect the mass number. That's one of those smaller particles that make up the atom. Now, Dalton did his work in 1803. He published his work. It was later in the century, around 1897, that J.J. Thomson published his theory, added to the atomic theory. And his theory concluded that atoms are divisible. He discovered the electron through a series of experiments using a cathode ray tube and charged metal plates. Now, you'll find a picture of this experiment in your book. And so there's also a picture showing his model in the background here. And I'll explain that a little more in depth. What he did is he took a cathode ray tube like this, and there was a positively charged plate and a negatively charged plate that he surrounded it with. And the rays, when the particles go through, he knew that they were negatively charged and they would hit the tube and cause a flash of light. And what he saw is that the hits that were happening in the tube were bent towards the positive plate. And he knew that they had to be negative particles in the cathode tube because like charges repel, so the negatives were repelling, and unlike charges attract, so the negative charges in the tube were attracted to the positive plate. And the deflections led him to surmise that atoms contain very small negatively charged particles that are scattered in a sea of positive charges. So that is what that picture in the background is depicting, these negative particles in a sea of positive charge. Sometimes this is called the plum pudding model. And there's a picture of plum pudding in your book if you want to see what that looks like. It's a traditional English dessert for Christmas, and it's basically a cake with a lot of raisins in it. So if you could think of a round cake with raisins in it, that is plum pudding. And so that's what J.J. Thomson was thinking of with his model. So after J.J. Thomson, the next person to add to our understanding of atomic theory was Ernest Rutherford, and there wasn't such a big gap this time. He came out with his findings in 1909, and his atomic theory was the result of experiments that involved alpha particles being directed at a thin piece of gold foil. Now, alpha particles are positively charged particles. He knew that they were positively charged, and he was shooting them at a very thin piece of gold foil. And surrounding this piece of gold foil was photographic film. And so he shot the alpha particles through the foil, and what he found is that most of them went through and hit the other side, and so you would see on the photographic film when you exposed it that's where they hit. But some were deflected, not many. So that's what the picture in the background is depicting. Because most of them went through, he concluded the atom is mostly empty space. And we can see here these arrows, most are going through. There's one being deflected because he said that the atom was mostly empty space. And his results are as follows. The atom is mostly empty space. There is a small, dense positive center called the nucleus. That's that red spot in the center where most of the mass of the atom would be contained. And electrons surround the nucleus. And that's getting a lot closer to our understanding of the atom today. So after Rutherford was Niels Bohr. And Niels Bohr published his findings in 1913. And he theorized that electrons travel around the nucleus in specific orbits or shells. And so that's what you see in the background. The black dots are electrons, and they are in shells or orbits, kind of like even rungs on a ladder surrounding the nucleus. This would be more three-dimensional, though, not just two-dimensional. And they can reside between the shells. They cannot, reside between the shells, but can absorb energy and jump from a lower shell to a higher shell. So he said they have to be on these shells. They have to be on these lines. They cannot be somewhere in the middle. Because they jump, this results in a less stable atom, so the electrons fall back down to the lower shell, releasing energy in the form of light. This is why we have fireworks. What you're doing is you are adding energy When you heat up certain chemicals, certain salts, you're adding energy to them, and when they atoms jump up to a higher level, they then fall down and release energy in the forms of different colors of light. Then, Erwin Schrödinger. Now, there is supposed to be an accent over the O, but I couldn't figure out how to do it. Okay. Erwin Schrödinger, he published his findings in 1926, and he developed what is called the quantum mechanical model or the electron cloud model. And so what he said is that the electrons aren't on these fixed orbitals, but they're found in certain areas. And you can see that in the pictures behind what I wrote. These are different electron clouds that can exist for the hydrogen atom, where you would find the electron from a hydrogen atom depending upon the amount of energy that the atom has. In this model, electrons exist in electron cloud regions around the nucleus rather than finite orbits. And you can see that in these pictures where you see the different colors of light shows where they're most likely to be found. And these electron clouds help predict where an electron is most likely to be found. Electrons are moving very fast. We cannot tell exactly where that electron is at any given time because it is moving so fast, but these are the areas where it is most likely found. It's kind of like a fan. When you turn on a fan, you can't really see the blades. If the blades have stopped, you can see them. So if we could stop an electron, we would know exactly where it would be. But when you turn on the blades of a fan, you see this like whir of color. That's like what an electron cloud is. That kind of where you see the blade where it's just all mixed together. That's like what an electron cloud is as far as where you would find that electron because it is moving around so quickly. So our objectives for this section were to analyze methods used to determine the structure of an atom, and some of those methods were using cathode rays tubes and alpha particles. To compare the 5 main atomic theories we talked about throughout this section, and to describe the current electron configuration around the nucleus, that is the electron cloud idea or the quantum mechanical theory. So you need to put 5 questions in your margins for this section, and I'll be back with more about the atom.